Good morning. So we're back today then for another lesson on genetics. What we're looking at today is blood groups, which is both a case of codominance and multiple alleles, both types of inheritance that we saw earlier on this week. Now we do know that your blood group, or you could also say your blood type, so whether you have type A, B, AB, or O, is all dependent on a particular protein or an antigen that is found on the surface of your red blood cells. Well, what protein is determined to be on your red blood cells is coded by your DNA, and therefore it is a genetic condition to have a particular protein over another. So this blood type is determined by the immunoglobulin gene. Immunoglobulin is the name of the protein. And there are multiple alleles for that immunoglobulin gene. So you can have immunoglobulin A, you can have immunoglobulin B, or you can have no immunoglobulin, and if you don't have an immunoglobulin protein being made on your red blood cells, then the allele that you have is little I, okay? Now, why do we say that we have multiple alleles and codominance? There's a particular way that these genes are inherited. So here what you're going to see is that the IA allele and the IB allele are codominant. Whereas both the IA and IB allele are dominant over little I. So we have multiple alleles because we have A, B, or little I, and then we have codominance because the A and B are codominant. So if they come up in the same genotype, then both the A and the B will show. So just like we did when we looked at multiple alleles, let's see what possible genotypes we can have for the phenotypes. So possible genotypes for the different phenotypes. So again, my possible phenotypes are, I can have type A blood, I can have type B, I can have type AB, and I can have type O, or in this case really should be 0 because you don't have any immunoglobulin on your red blood cells. So for type A, what I can have is I can be homozygous for A. Oops, I say A. Or I can be heterozygous for A because A is dominant over the little I. So I could be heterozygous for A and have little I as my other allele. For B, same idea. I could have homozygous for B, or I could be heterozygous for B because B is also dominant over the little I. For AB, this is where the codominance comes into play. So for AB here, I would have IA and IB. So if I'm heterozygous for B, or if I have A and B together, I would get the AB blood type. And the only way I can have O as a blood type is if I have both of the little recessive alleles for the gene, okay? So let's take a look at what a problem with blood groups might look like. So we're gonna have a woman with blood type A, whose mother was type O, mates with a man who is type B, heterozygous. So they're telling you their genotypes in a couple of different ways. So for the man, they're telling you that it's heterozygous, and for the woman, they're telling you that her mother was type O. So we know when we're doing this, let's say that I was writing down, okay, so she's type A, her mother was type O, so what is the only thing her mom could give? So the only allele her mom could give her is a little I. So I know that this woman is heterozygous for her blood type A. And then she's mating with a man who's type B, heterozygous. So they're telling you that he has the little I for his genotype. It says write the possible phenotypes of their children. Okay, so now here what I need to do is I need to do a Punnett square. And so I have the woman and I have the man. So their first child is AB blood type, B, A, and I. So what are the possible phenotypes? Again, it's not asking for a ratio, it's just saying what are the possible phenotypes. So the phenotypes for the babies, it could be AB, A, B, and O. Those are the possible phenotypes. And then it says, what is the probability of a girl with type O? So again, for this one, I have to do this separate. It's my product rule, right? So what is the probability of having a girl? So for that, I have a half. And what is the probability of type O? I know that it's only 1 out of the 4. And so for that, I'm gonna do times 1/4 for that. Multiply the top, multiply the bottom. And so I get 1/8, or if you want to write it in percentage, is 13%. And that is it for blood groups. I hope this helped, and we're going to see you just in a little bit with sex-linked inheritance.